Section 3.3, conversion problems. So here's our key concepts. What happens when a measurement is multiplied by a conversion factor? Everyone know what happens there. Why is dimensional analysis useful? And what types of problems are easily solved using dimensional analysis? All right, so what are we talking about when we're talking about a conversion factor? Well, first of all, we're talking about two measurements that are equivalent. And if we take two measurements that are equivalent, we can create a ratio of them that equals 1. In other words, if we say that 1 meter equals 100 centimeters, I can create the ratio 1 meter over 100 centimeters. Since they're both the same, they would cancel out to be 1. Or I could do it the other way around, 100 centimeters over 1 meter. Those are conversion factors. So, conversion factor is a ratio of equivalent measurements. They've got to be the same. You can set them on top of each other and make a ratio. The larger number is part of the measurement with the smaller unit. In other words, if you look at this, here's the larger number, 100 centimeters is a smaller unit. 1 is a small number, meters is a bigger unit. That's what they mean by that particular statement there. So here's my example, 1 meter over 100 centimeters, larger, smaller, just kind of what we were talking about. If you measure something, if you multiply something, rather, by the conversion factor, you might change the numerical value, but you're not changing how much it really was because you're multiplying by a factor that's equal to 1. So we can do some examples of converting here. If we think about, let's say that I want to change from meters, let's say I have 7 meters, and I want to convert that to centimeters. My conversion factor, we said, 1 meter equals 100 centimeters. And I can create two ratios, one like this, 1 meter over 100 centimeters, or 100 centimeters over 1 meter. What I want is to put a conversion factor that will cancel my meters. Since meters are over 1, really, I need to have meters on the bottom. So I need the one that has 1 meter on the bottom, 100 centimeters on the top. This will cancel. I would get 700 centimeters. So when we're talking about dimensional analysis, it's simply a way to use these conversion factors that we were talking about to change units. So it's just like the problem that I did would be an example of using it in dimensional analysis would be the same kind of thing that we were just doing. So we could just convert from one thing to another. Let's do one more. Let's say that I wanted to know, let's say I have 175 grams, and I want to know how many kilograms that's going to be. So I always set them up that way. What am I trying to find? I put here equals, what am I given? I want everything set up this way. 1 kilogram is equal to 1,000 grams. So you have to know some basics. You got to know those types of things. And from that, you can then create your conversions. Once again, you can create two. 1,000 grams over 1 kilogram, or 1 kilogram over 1,000 grams. What we want is the one that cancels and gives us kilograms. So if I want to get kilograms and it's on top here, my answer, or my factor that I got to use, got to have kilograms here. If I want to get rid of grams and it's on top, I got to get grams on the bottom. So either way, you look at it either way. Those cancel. What I'm going to do is take 175 times 1. Well, that's the same thing, so it's still 175. Anything on the bottom, I'm going to divide. So 175 divided by 1,000 would give me 0.175 kilograms. Let's take a look at this problem. It says, how many seconds are in a workday that lasts exactly 8 hours. How many seconds equals 8 hours? Well, we need conversions. We need to go from hours to minutes, minutes to seconds. So from hours to minutes, 60 minutes. Minutes to seconds, 60 seconds. So we need to set it up in such a way that those cancel. So to go from hours to minutes, I need to put hours on top, or on the bottom rather, to make it cancel with this one. So 1 hour on the bottom, 60 minutes on the top. Well, I don't really want to do that. Thank you so much for your annoying thing. I've got 60 minutes on top. I want to make those seconds, so I need to put minutes on the bottom. So 1 minute, seconds on the top, 60 seconds. If I do this right, you should be able to cancel out everything but the term that you're looking for. So in this, I'm going to take 8. Anything on the bottom is a 1, so those aren't going to make any difference. 8 times 60 times 60, and that's going to come out to be 28,800 seconds. I want you to do now 28 and 29. So stop the video and do those two. Hopefully, this is what you got for an answer. For 28, you would get 1, 0, 0, 8, 0 minutes. And 29 is 1, 4, 4, 0, 0, 0 seconds. Now, I'm not working through those now, but if you want to see how those were done, you can watch the other video, which has some sample problems. It has these sample problems on it, but in the sake of time, I can't get all that in 15 minutes, so you'll have to watch those videos if you need to see that. If you got the answers right, you're probably good. Okay, let's go through another one. On the next one, it says the directions for an experiment ask each student to measure 1.84 grams of copper wire. The only copper wire available is a spool with a mass of 50 grams. How many students can do the experiment before the copper runs out? So what we know is we've got 50 grams of copper and we need 1.84 per student. So here's my factor, or my ratio, that I'm going to use, and I want to figure out how many students. So I'm going to say, how many students can I get from 50 grams of copper? Now this might be a unique way of doing a dimensional analysis problem. You may not have done, I mean, you've done problems like this before, but maybe not in a dimensional analysis way. But take a look at what I've got here. I've got a ratio, 1.84 grams per student, and I want to make it cancel. So I can use it either way. I can use it with 1.84 on the top or 1.84 on the bottom. Since I want to end up with students and I want grams to cancel, I better get grams on the bottom and students on the top. So therefore, my answer ends up with students and grams cancel. So the way to do this is going to take 50 divided by 1.84, and that's going to get 27.174. Obviously, I can't get tenths of students, so the answer is 27. All right, do 30 and 31. Stop the video. I'll tell you the answers here in just a second. Once again, if you need to see them done, they will be on a separate video. Okay, the answer for number 30, 67. The answer for 31, 86.4. All right, let's clear that.